Hello, welcome to PhyzQuest. So this is the solution video for CSIR NET December 2019 Part B, question number 13. So the question is, a mole of a gas at initial temperature Ti comes into contact with a heat reservoir at temperature Tf and the system is allowed to reach equilibrium at constant volume. If the specific heat of the gas is Cv is equal to alpha T, where alpha is a constant, we need to calculate the total change in entropy. 4 options are given and we need to calculate the correct option. So let's get started. This question comes from the section Heat and Thermodynamics, and the concept involved here is entropy. So first of all, what is entropy? In common terms, it means disorder or chaos. But in physics, to understand entropy, visualize a system where there are certain number of atoms which are like this. When heat is supplied to the system, the atoms gain the heat energy and starts their movement like this. So earlier, when atoms were concentrated in a particular region of the system, to spreading throughout the system, what is happening here is there is a change in state of the system. Now the atoms are not going to stay as it is. They keep on moving throughout the system. So every time there is a change in position, that would be a new state of the system. So when these atoms are bouncing around in different ways, there would be more number of different states of the system. So here the concept of entropy comes in. More the number of states it can have, more would be the entropy of the system. So that is the reason why when temperature increases, entropy increases. Now consider another situation. Consider two bodies, one is hot body, another is cold body. When both of them come to contact, heat transfer will take place from hot body to the cold body. That means temperature of the cold body will increase and the temperature of the hot body will decrease. That means entropy of the hot body will decrease and the entropy of the cold body will increase. But even the total change of the entropy will be positive, because the decrease in entropy of the hot body will be comparatively smaller than the increase in entropy of the cold body. Now coming to the question. Here we have a mole of gas at temperature Ti and a heat reservoir at temperature Tf. So when the gas comes into contact with the reservoir, here one thing is the situation is slightly different as compared to the previous case. Here when both of them comes into contact, the temperature of the gas will increase, but the temperature of the heat reservoir is not going to change. You can understand it with a simple example. Like here, for example, you have a fire where you keep a container. Here the contents of the container, the temperature will rise, but the temperature of the fire will not going to decrease. It will remain the same. Same situation is in the given question. The temperature of the heat reservoir will be the same. Only temperature change will take place in case of the gas. Now we have to calculate the total change in entropy at constant volume. That is, the condition is given in the question. So the total change in entropy will be delta S, which has a contribution from change of entropy of the gas due to absorption of heat plus the change in entropy due to the heat given by the heat reservoir. Now it is by the formula of the change in entropy is delta S is equal to dQ by T. Now here this will be, if we put the same formula, this will be equal to integration from Ti to Tf dq by T plus integration from Ti to Tf in dq by Tf. Why Tf? Because here the temperature will be the same. There will be no change in temperature here. Now what is dq? As per first law of thermodynamics, dq is equal to dw plus du. So now this is dw is equal to pdv, so pdv plus du. Now it is given that we have to calculate the change in entropy at constant volume. So constant volume means the first term pdv will be 0. That means dq is equal to du. So again, as per the formula, du is equal to n Cv dt. Now in the given case, now here n is the number of mole. In the given case, there is 1 mole of gas, so n is equal to 1. And the specific heat Cv is given as alpha T. So dq will be equal to alpha T dt. So we'll put the same value in this integration term. So this will be equal to integration from Ti to Tf alpha T dt divided by T plus integration from Ti to Tf alpha T dt divided by Tf. Now in the first term, Tt will get cancelled. So this will be equal to alpha, the integration of only dt will give T from Ti to Tf plus here alpha and Tf both are constant terms. So and the integration will take place for T dt, which will be T square by 2. So this will be alpha by 2 Tf T square from Ti to Tf. So upon putting the limit, ultimately the final term will be equal to alpha Tf minus Ti plus alpha by 2 Tf Tf square minus Ti square. So this is the total change in entropy. Now let's look at the option. Now if you look at the option, you can see that option D is matching with the result. So the correct answer for this question is option D.